Hey guys, welcome to Technical Ecology. This is Kalpran and welcome back to episode 5 of the R series. And in today's video, we are going to talk about arrays, which is the last segment of the matrix series. After that, we are going to jump into more of the ecological theories and the statistics behind ecology in the later videos. But in today's video, we are mostly going to talk about arrays. Without much further ado, let's get into it. Alright. So we have our script open. As you can see from the script itself, it's a fairly short video, but most of it is the explanation of how arrays work. So this video is mostly going to be the explanation of arrays with just a few lines of code. So what are arrays? First of all, arrays are multidimensional matrix, which like I told you earlier in the earlier videos. So like we know in matrix has 2 dimensions, right? So it has the number of rows and the number of columns. However, in arrays, we have a third dimension. It's just like a 3D rectangular prism. So you can think of it as a cube, but each vertices of the cube has its own index. So in matrix, we have the number of rows and the number of columns, but in arrays, we have the number of rows and the columns, and a third element called layer. So the third element, the layer, it's much more difficult to explain to you by just talking, so I will just jump right into my iPad. Let me have this open, then I'll do it in real time and show it to you. So let me quickly draw an array first and then I'll get back to you. Well, so I also want to say that just as a matrix is considered to be a collection of vectors of equal length, a three-dimensional array can be considered sort of like a collection of equally dimensioned matrix. So if I say matrix is of the dimension 2 by 2, then an array can be an object which can have 2 or 3 matrix all together, but in a 3-dimensional space rather than 2-dimensional space, which is the case for matrix. So even in an array, even in an array there is fixed number of rows and fixed number of columns, but we have an additional element called layer, which is the 3-dimensional element. So if we have 3 axes, x, y, and z, so x is the x-axis, y is the horizontal axis, and z is the 3-dimensional axis, that we can't show it on paper, but it is there in 3 dimension, in space and time. So to create a data structure in R using the array function, we again have certain codes like the code array. It's very similar like the matrices. In array, you just mention the data in and then you put the dimensions, whereas in dimensions, in case of matrix, we just used to put the number of rows and the number of columns, but here we'll also put the number of layers. So the more number of layers, the bigger the matrix will be in 3D space. By bigger, I don't mean in value, but in 3D space, in the space it occupies in reality. And like I told, that 2 matrices may make up an array, and if you want to make an array in 4D space, like right now 2 matrices build 2 matrices, sorry, not matrices, 2 matrices build up an array in 3D space. But now if you want to make an array in 4D space, then you'll need to stack up 2 arrays. So it will be very clear when I am done drawing this. So let me just finish it up. So here we have it. So this is our array, and you can see here that I have written these points down. And so these points basically are the dimensions or the specific index of each data point in an array. So every point here, let me just clean it up a bit. So every point here, let me choose red. These, this, here, all these red points and the blue points, all of these contains values. So all of these will store data that we provide it to store. Like a matrix, how in a matrix, if I just quickly draw a matrix, it'll be very rough. So if we have let's say 2 by 2 matrix, so in matrix, since it's in 2D space, this entire block, let me just change the color, this entire block, all these blocks will store data. Since these blocks will store data, let's say this one stores the value of 7, this one stores 8, this one stores 9, this one stores 10. Since it's in 2D space, it can store data in all of these blocks, and each block has its own index. So this one is 1,1, this one is 1,2, so first row second column, and this one is second row first column, and this one is second row second column. Yeah. However, in case of matrix, since it's in three-dimensional space, it stores values or data not in individual sites or inside in the centroid of one box. So let's just quickly try and disseminate this entire big array into just 2 small arrays for easier understanding. So let me quickly draw that. So we have one box here, one box there. There we go. So you can see it. This is in 3D space. Now if I do the same thing, okay, I'm getting a bit confused. There we go. There we go. So this is the part behind it, and if we have to look towards the front, this is the bottom part, and then one will come here, one will go there, and it will basically be, yikes, there. Yeah, so we have this. So this is basically a three-dimensional array. Yeah, so this array, let's try and figure out what are the dimensions of it. In that process, we will be able to identify what are the points where the data is stored. So like in the case of a matrix, the data is mostly stored in each block in 2D space. So it's not stored in these vertices. Yeah, it is just stored somewhere in the space here, in the area of the in the surface area of the matrix. And a matrix, it doesn't exist as an object or a thing in space and time. So it's just a mathematical tool that we use to store data, calculate data, and various sort of things. But in case of arrays, even though it doesn't exist, but we have to visualize it in a 3D space. It is very tempting for us to assume that, okay, one cube, like a matrix, one square, will hold one data point. So let's say we assume that it stores a data point right here in the center of this cube. Yeah, so this is a cube. So let me quickly pull up my, yeah, so this is the cube. Yeah, so this is the cube here, and in the center of it, the red point is where the data is stored, which is our assumption, but that is not the case. In case of arrays, the data is not stored, like one cube is not the source of just one data point, but each vertices where the dimensions meet are the storage point of our data. What I mean by the point where the dimensions meet is where the axes is. So here we have, this is our x-axis, this is our y-axis, and this here is our z-axis. Yeah. So what is the converging point here? Well, it's very easy to visualize here. This here is the converging point. So this point is where the data will be stored. Yeah. So this is where the data will be stored. But it's not just this. We have many axes like this in this entire array. So we have another point here. We can say this is the x-axis, there is the y-axis, and this is the z-axis. However, if we stack up another cube like this on top of, let's say we stack up another object here, then we can store values here as well in this point as well. But just for simplicity's sake, we are not doing that. Let me get rid of that. Yep. So here again, the converging point is this one. So another value is stored here. Similarly, another example, where is my pen? There we go. Y-axis, z-axis, x-axis, and z-axis. Converging point, data stored there. Converging point, data stored there. Converging point, data stored there. So now let's try and get the indexes for each data point. Yeah. So here we have, you can see that if we have to find the index, first we need the number of rows. So let's calculate the number of the row number in this one, in this point. Yeah. So what's the row number here? We know here that the row number is 1. What's the column number? Well, this is the first column, so first. And what is the layer number, which is in, again, 3D space. So the layer here is towards the front, so we always go from front till back. So this is the first layer, so it's 1, 1, 1. However, what is the index of this one? Right, so let's do that again. This is the first row, so you can see it's just one behind another. So it's not different rows altogether. Rows are numbered when one is above or below each other. So if one is above, then that's 1, and the lower one is 2. However, since it's in 3D space, it's on the same level. So here, this entire thing is row 1, but this entire thing is row number 1 as well, because it's on the same level. So here is row number 1. Similarly for columns, this is the first column. Change the color. This is the first. Let me change the color. This is the first column, and this is the second column, third column. Similarly, first column, second column, third column, because on the same level. So the column number here is 2, so 2. And the layer, what's in front of us? This is layer 1. This is layer 1. Let me highlight it, it'll be easier. Oh god. So yellow. So this is layer 1, is towards the front part. Yeah. If you go behind, let me change the color, that part there in the back, yeah, that is layer 2. So the dimension for the layer equals to 2. So the index of this particular vertex is 1, 2, 2, and this one is 1, 1, 1. This one will be 1 comma 3 comma 1. First row, third column, first layer. In the same manner, I have calculated, I have named the indexes of all these indexes, all of these. Yeah, it's very messy, but yeah. And if I have to, again, for the last example, have to, let's say, get the index of this particular point, so it will be, let's just do that. Second row, number of column, 1 2 3 4. So this is 4, so this will also be 4. Was the layer, the second layer, because it's behind. This is the first layer, second layer, first layer, second layer. So 4 comma 2 comma 4. Now I have also mentioned here what's wrong in this point. Well, you can pause the video and try to sort that out, and then play to see the correct answer. Well, the correct answer is that here I told data is stored where the three axes meet or they converge. Here you can see, okay, we have the y-axis here, we have the y, we have the x, but where's the z-axis? We don't have a z-axis here because no point converges there, no cube sticks on to the other cube there. So since no z-axis, this one doesn't store any data point. Now that was all about arrays, and I hope you understood how arrays work. Now if I'll jump back to my R screen, so you can see that to create an array there is a very simple function called array. So you just put in the data. For this case, it's like I want an array which has data from 1 till 24. So in an increment of 1, so 1 2 3 4 5 6 so on until 24, and the dimension is a 3 comma 4 comma 2, which is 3 rows, 4 columns, and 2 layers which we drew. So let's run this, and then I'll run that. So you can see here it first shows you the first layer, which is 1 comma which is again a matrix on itself. So you stack up two matrix, then you get an array, and in the second layer there is again a matrix itself. So what if you want to subset or extract elements from a matrix? Let's try and extract the second row, but all the elements in the second column of the second row of the second layer. So let's see what that is. Like before even running the code, let's try and figure it out here. So we can see it is extracting from the second layer, right? So this is our second layer. So what is the second row in this matrix, in this layer? So in this matrix, the second row is this one. So it will extract 14, 17, 20, and 23. Let's see if you're right or wrong. Yeah, you can see it here, 14, 17, 20, and 23. Similarly, if we in here we want to extract just second row and the third column, and the element in the second row and third column, and the element in the second row and the first column of the second layer again. So here, so second row, third column, we have 20, so it will extract 20, and it is going to extract 14. So let's try and run it. See, 20 and 14. So what if you want to extract multiple vectors, like from an array? If you do that, it will always return a matrix. So let's say we want to extract the first row of both the layers and all the columns of it. So basically what we are saying is we want to extract 1 4 7 8 10, and we want to extract 13 16 19 22. Now these two are one behind the other. So how will R interpret it? It'll create another matrix for it. It can't show us in 3 dimension, so it'll basically create another matrix which will be filled up like we spoke earlier. R always tries to fill it up in a column-wise fashion. So the first row and all the columns here is 1, 4, 7, and 10. It will be filled up in a column-wise fashion as the first column in the new matrix that is thrown off, which is 1, 4, 7, and 10. You can see here 1, 4, 7, and 10, and from the second layer it is going to extract 13, 16, 19, and 22 and put it in the second column. So whenever you are extracting multiple number of columns from two layers, from continuously from like simultaneously from two layers, then it is always going to give you a matrix, and the matrix will always be filled in a row-wise fashion, in a column-wise fashion. So that is basically about arrays, and I feel this much of knowledge is more than enough for playing with arrays and for working with arrays later, much later in the videos. We have arrays, how to manipulate arrays or how to work with arrays, especially in ecological data. It comes towards the very end, because in ecological data we mostly deal with matrices, like for chi-square or anything, or tables for that matter. So with that being said, we have come to the end of this video, and I hope to see you in the next one. Thank you for watching.